Uh, Hi, we were discussing about pointers, okay, and we had seen an example to pass pointers as parameters to a method, okay. Right. Now let us see one more example, just to get familiarity with pointers, okay. See here we have an array, okay, and it's a pointer to an integer, but we are not initializing this to anything as of now, okay, right. So here we are initializing this pt to see if you say var of 0, we just get the value in that, but you want the address of that, okay. So the base address is being stored in pt, okay, and we want to just add the content, okay. So pt is pointing to an element, so if you want to get the content of that element, we need to say star pt, okay. Fine. So in this way, the PT is, I mean, getting traversed through each element. Okay. Meanwhile, we are using I. Okay. So I is initialized to 0. Okay. Until the number of elements, like we keep doing it. Okay. Fine. And we are just putting the sum. Okay. So let me just run it. Okay, so we are getting the sum. I hope it's right. 1, 2, 10, 20, 30, 40, 50. Okay, right. Next. Now, can we see we are creating objects for a class? Okay. Now, the point is, can we create and where were these objects stored means all the objects until now, okay, were stored on the stack, okay, stack segment, okay. Say, for example, we want to store the object on heap, then how can we do it? Okay, so let us see an example for that. Okay, right. So let's create a new source file. Okay, and we'll be naming it as, okay, object on heap, okay, dot cpp. Right, so it got created. Fine. So let's write the program. Should include, I have a string namespace std. uh, let's have a class and let us name it as, let's name it as, okay, something wrapper. It will just wrap some value in this, okay, right. So let us wrap, so let us assume there is a integer value, okay, and it will basically wrap that one, okay. Fine, let's have a constructor, okay, public constructor wrapper, okay, and let me initialize the value to something, okay, and let's also have a destructor, okay. So wrapper destructor, okay, fine. So wrapper constructor, okay, fine. Now our aim is or moreover we can take it as a parameter. Okay, so let's say int and value 1. Okay, value is fine. Okay, and val equal to value. Fine. Okay, now let's write the main method. Okay, and let us create an object of wrapper. Okay, so wrapper star pointer to object equal to new wrapper. Let us pass 23. So here, this is the way we created the object. Now the object is created on the heap. Okay. So because we are allocating the memory using heap. Okay. Right. And this object doesn't get destroyed when you are going out of the scope. Okay. So it is the programmer's responsibility to manually delete it. Okay, it could be either here or maybe outside, but if it is outside, ensure that uh, this pointer is has the required scope to access in some other method. Okay, right. So let's assume I want to destroy it here. Okay, right. As already seen, delete is the keyword used. Okay, right. So, and along with that, we need to specify the pointer. So let us try to execute it. Okay, so as you can see here, the constructor and destructor. Okay, right. So basically, by creating an object on the heap, you have the comfort of allocating it wherever required and deallocating wherever required. Okay, right. Fine. So, and one more point is, even we can have array of objects. Okay, right. Yes. So, as we were discussing, it is possible to have array of objects. So here we have created array of objects, but be cautious that uh, it's the array objects are created on stack. Okay, not on the heap. Okay, fine. So anyhow, it gets destroyed once you go out of this code. Okay, so we are talking about two different concepts. This is about an object on the heap. Here we are talking about uh, array of objects. Okay, right. So let me of objects, array of objects and object on heap. Okay, fine. So let us take a backup of it. Okay. So at this point of time, I just want to, and one more thing is, whenever you're creating an array of objects, it will implicitly it will call default constructor. So that is the reason I provided default constructor. Okay, because it was me compiler error. Okay, right, fine. I just want to discuss something about this keyboard. Okay, right. So let us do something like this. Okay, let's have the parameter as val itself. Okay, and I have like this. So here there is a name collision, even data member, val, and even the parameter is val. Okay. So how you can avoid such collision is, okay. So by doing like this. Okay. So excuse me. Okay. So what we did here is I'm receiving as a parameter and I'm referring to the val of the current object by using this. So as already said, this is pointer to current object and it is provided to us as a keyword. It is a keyword. Okay. It is already pre-created. Okay. All right. Now let us try to execute. Okay. I'll try to remove this array of objects. It's not required now. Okay. Okay. Fine. So here this keyboard is used. So one of the main purpose of this keyboard is to avoid the name collision between uh, okay data members and parameters or local variables. Okay, they have same name, right? And it's not that you can only refer to data members. Even for any specific reason you want to refer to the methods of the current class. Okay, so you can do it by using this. Okay, and even you can invoke methods. Okay, fine, which are in the current class. Fine. Let me rename it. And so here, okay, so this example, this keyword, it's a keyword actually, example. Okay, fine. So until now we have seen what is a class, the access specifiers, pointers, creating object on stack, on the heap, array of object, passing object as parameter, returning object, etc. Okay. So now it's time to move to the next concept, which is inheritance. Okay. So as I was initially explaining, okay, one of the advantage of object-oriented languages are reusability. Okay. That means that means whenever you have a class with some functionality and the same functionality you want to reuse in many other classes. Okay. When you want to directly use it, you can create object of it and use it. But let us assume some other classes wants to use this functionality. Then one of the way is we can say, for example, we already have a class A and there is a class B and class B needs the functionality of class A. Then class B can extend from A. That means A is the base class, B is the derived class. So let us see some examples also. Okay, right. So derived class inherits all the properties of base class without making any changes. So facilitates code reuse and reusability. Okay, right. So see, whenever you are inheriting, you need to specify what is the access specifier based on which you are inheriting. Okay, right. See here I have a class demo A, B, C. Here obviously we know A is a private one default and B is protected, C is public. Okay, right. So whenever I'm inheriting like this, it is class B and I'm inheriting class A publicly. Okay, that time what happens is all public members becomes public member. All public members of the base class becomes public members in the derived class. Okay, hence accessible by derived class objects. Okay, fine. And whichever are protected remain protected. And obviously, whichever private members at any cost, it cannot be accessed outside the class. Okay, irrespective of uh, the way you inherit. Okay, right. So let us assume you inherited in a protected by using protected inheritance. All public and protected members, okay, become protected in the derived class. Okay, so accessible only by members. Okay, okay, and friends of the derived class. Fine, right. So all of them are derived. I mean, public protected are derived as the protected in the derived class will be available as protected. Private means public and protected members will become private members in the derived class. Okay, and obviously when they become private members, that cannot be accessed outside the class, and even in the derived class also we can't access. Okay, right, fine. So one of the main advantage of inheritance is reusability. Okay, and there is one more advantage which is polymorphism. Okay, we'll see about that in next few minutes. Right. So actually, based on the derived class, base class, how they are related, based on the number of classes in the relationship and how they are related. Okay, there are five different types of inheritances. Okay, one is single inheritance, the other is multi-level, multiple, hybrid, and hierarchical. First, let us take a look at what is single inheritance. As the name says, there is only one base class, there is only one derived class. Okay, right. So let us see the diagram. See, here you have class A, here you have class B. Okay, and class B is the derived class, class B is the derived class, class A is the base class. Okay, so why this arrow mark means? This is to say that class B is dependent on the functionality of class A. Okay, dependent means, okay, that entire whatever the content of A, okay, mix is gets available in B. Okay, right, except project members. So whenever you are inheriting, okay, you can inherit it publicly, private or protected. We already know that, we just see it. Okay, right, fine. This is single inheritance. So in single inheritance, only one base class is involved and one derived class is involved. Okay. Next is multi-level. Okay. So why don't we just take a look at an example and come back? Okay. Fine. Yeah. So we have an example here. So we have a employee class. Fine. And we have salary. Okay. Fine. So this salary class wants to reuse the functionality of EMP class. Okay. Right. So here we are specifying the inheritance relationship. Okay. And so here we created objects of salary, array of objects of salary class. Okay. And we are just calculating, performing some calculations here. And finally, we are traversing through each element and we are putting the details. Okay. Right. So Right. So if you closely observe here, this is an array of objects. Okay. And here we are traversing, iterating through them. Okay. Uh, right. And here we are invoking get and get one. Let us see the difference. Okay. Okay. Right. So the get one is in the base class. Get is in the base class. Get one is in the derived class. Okay. Right. So basically, these are the objects of salary, and salary is the derived class of, okay, salary is the derived class of EMP class. Okay, right. So all the functionality which is available in EMP now is available in salary class also. Okay, so that is why by using the objects, we are able to call the methods of both base class, okay, non-private methods, and derived class non-private methods also. Okay, right. So there is no rule that wherever you want to use inheritance, you have to do only with array. There is no such a rule. Okay, right, fine. So that is single inheritance. So we have one base class, one derived class. I mean, whether you derive it publicly or privately or protected, or that's up to the requirement. Okay, single inheritance says only one base class, one derived class. It doesn't say inherit it in public, private, or protected. Okay, fine. Right. So that is single inheritance. Now let us take a look at multi-level. As you can see, okay, here there are, okay, here at the B is a derived class. This derived class acts as a base class of some other class. Okay. So basically there are multi-levels, just like floors in a building. Okay. Right. So A is the basemost class, B is the derived class of A, and C is the derived class of B. Okay. So code skeleton wise, it looks like this. Okay. Right. So, right. So in this specific case, we know that all the public members of A will also become the public members of B. So here B is called intermediate. Okay, all the public properties of A are available in C. Okay, that means if it is public here, then since we are publicly inheriting, here also it is public. Now, okay, we are saying class C derives from class B. Since it is public here and it is inherited, it will be available here, okay, as public only. Okay, right. And obviously the private members of A, okay, irrespective of whatever you specify here while inheriting, it cannot be accessed, okay, in the data class. Okay, so that is multi-level inheritance. Okay, fine. And one more thing is here we had seen only three different levels A, B, C, but there is no rule that there need to be only three levels. It says like three or more levels. Okay, fine. So let us see an example for that. Okay, so in case of multi-level, we have a employee base class. Okay, and we have salary derived class. Okay, then we have bank credit. Okay, so bank credit is the derived class of salary. So here we are creating object of bank credit. Okay, and we are just iterating through the elements. Okay, of array. Okay, So here also coincidentally it's array, but don't think that on base and derived class only we can use array. Okay, even you can do it using individual objects. Okay, fine. So whenever you are using this bank credit, okay, here we are invoking get bank details and display. Okay, fine. So get bank details is there, okay, and display is there, okay. But here salary display, get paid details, okay. So we have much many things. But here what is happening is whenever get bank details is called, we are in turn calling get pay details. Okay. So where is our get pay details? Yeah, here it is. But here in this get pay details, in turn we are invoking this. Okay. Like so basically all this hierarchy gets um, invoke the methods one after the other. Okay. Right. So this is an example for multi-level inheritance. Okay, right. So I think we need to change the code a bit because it is based on the uh, okay, old version, I suppose. Okay, fine. It's not in a valid project. That's why. Okay, right. Let us do one thing. Let us try to write our own example for multi-level inheritance. Okay, let us take this single inheritance. Okay, and let us change it for multi inheritance. Okay, right. Say for example, I have single inheritance. In this, I have, say there is class A, then I have class B. Okay, so I'm inheriting from A. Okay, then okay, so here say I have int I. I just made it public just to check, but it is a good practice to put all the data members as private. Okay, unless and until okay, it, it shouldn't be based on the requirement. Okay, fine. Then say here we have int j. Okay, then let us assume we have class C. Okay, then public B. Okay, public int k. Okay, fine. Now what we will do is let us create an object of class C. Okay, and let us try to access all three okay data members. Okay, right. So now we are not directly creating an object of A or B. Okay, so we will create an object of C. Okay, so object of C, I'll say OC. Okay, all right. I'm creating on the heap. Sorry, on the stack. So that's why I'm not using new keyboard. Okay. Um, okay, fine. So now my aim is I just want to access I. Okay, and to access J, and want to access K. Fine, and say I can print all of them, but I'll just print one of them too. Maybe I'll print OC.I. Okay, right, just to check that that is being inherited by the derived most class. Okay, right. Okay, so looks like there are some compiler errors. So no such file or directory. Okay, fine. I think the normal changes which I do, and okay. So without dot h means if it is directly IO stream, then that means those are template based, all template based declarations. Okay, right. Dot h means it was non-template, right? So we haven't yet discussed templates. We'll see in the next sessions. Okay. So using namespace std. Okay, fine. Looks okay. So we can, okay, so the value 10 is printed. Okay. So IJK, okay, I is 10. Okay, fine. So an example for, this is also an example for multi-inheritance. And one more point is, see, we have a base class constructor, derived class constructor. Maybe you may be thinking which object gets created first. For example, I'm creating a derived class method, sorry, derived class object. Then which constructor gets invoked? Means let us just try to write a constructor, and so cout a, okay, and then let us put it public. Okay, else that cannot be uh, called from outside. Okay, let us copy the constructor. So as seen here, we have class A, class B, and class C. Okay, and here we are just creating the object of C. We are not creating directly. We are not creating the object of A and B. Okay. So now what will be the order of execution of constructor means? See, whenever you are creating an object of C, for this to be created, it needs base class object to be ready. So this in turn goes and calls the base class object. But this class is dependent on A. So again, it goes to the constructor. So the conclusion is first we will get this executed, then this, then this. Okay. It is just like first four, second four, third four, like that. Okay. So first four cannot, sorry, second four cannot exist without first four. Okay. Like something like that. Okay. So as you can see here, okay, the constructors are called in this order. And by any chance, if you have destructors, okay, in this, in case we place destructors, then the destructors always get invoked in the reverse order. Okay, because first the derived most object need to be cleared, then after that its base, then after that its base. Okay, all right, Fine. So let me rename to multiple inheritance and I'll just put constructor. Okay. Multiple inheritance constructor. Okay. Fine. So let me write it up. Fine. So we are seeing single inheritance. We are seeing multiple inheritance. Which one to use? That depends on our requirement. Okay. Fine. Okay. Next is multiple inheritance. So in case of multiple inheritance, okay, a base class, okay, sorry, a derived class has, as you can see here, C is the derived class. A derived class has more than one base class. There are two base classes. So all data members and methods from these and method from B as well, both are made available in C. Okay, so this is called multiple inheritance. And one more thing is here there is no rule that there should be only two base classes. There can be multiple base classes as well. Okay, more than two, right? Fine. So derived class has all the public and protected properties available. Okay, each base class can be inherited with any visibility. Of course, we already know that you can inherit with any visibility. Okay, right. So let us see if we have any example for multiple inheritance. It is there. Okay, I think it is there. Okay, yes, we have it. Okay, fine. Okay, so it is multiple inheritance. That means there is student details. Okay, student class. There is sports class. Okay, so okay. Then both student, there is a statement, okay, for which both are base classes. That means the functionality of both the classes becomes available. So that is why we created an object of statement. We are invoking get sum and display. So get method display is here itself. Get and get sum. Let us see where it is. Okay. So get sum is here and get is here. So when we are inheriting with the appropriate access specifier, okay, based on the access specifier of the method, okay, that becomes available. Okay, that derived class. Okay, so get sm. So here we are creating an object of statement. Okay, all right. Okay, let us remove that CLR SCR because anyway here we do not have to clear the screen. It's getting cleared every time. So enter roll number, I'll say 1. Enter the two marks, I'll say 34 and 45. Enter the sports mark. Sports mark, I'll enter 16. Okay, right. So it has printed. Fine. So basically, the bottom line is, in case of multiple inheritance, there are more than one base class. Okay, right. Okay. So